Hi everybody, welcome back for another notes. Hopefully Unit 3 is done and over with for you and you're excited and kind of feel like you can relax. But we're going to go straight into our next unit, which is Unit 4. And today we're going to be talking about slope. Okay, and look, I made it slope like a mountain. Haha, see? Okay, see how cool. Alright, moving on. So, what is slope? That is our first thing. Well, slope is the ratio. Yeah, I can't talk even in the videos. The ratio of the vertical change to a horizontal change between 2 points. Okay? So that's, yeah. Alright? And this is what it looks like. So M is a way to say slope. Oh, wait, I skipped something. Also known as rate of change. So when you hear someone say, what is the rate of change between these two things? They were talking about slope. Here's what it looks like algebraically. We will use the letter M to denote it. Okay, so whenever you see the M from now on, in this context, it means slope. Okay, y2 minus y1 over x2 minus x1, that's the formula for slope. It will, I want to say it's on your formula sheet, don't quote me on it. I think it might not be, I'm sorry. Might not be. But on a graph, it's really easy because it's just rise over the run. Okay, but this y2 minus y1 deal, that's the better way of saying it. That's the more intelligent way of saying it. Rise over run is like, Understanding that it's y2 minus y1, that's the better way, and that's what you're gonna have to use in high school, or else teachers get mad. Okay? Moving on. Types of slopes. So there's 4 types of slopes. Okay, and that they're determined based on like how the line, slope is always of a line, and how the line is formed. So if it's sloping down like this, that's negative. If it's sloping up like this, that's positive, maybe positive. You might have seen it in my class. Or nice, negative. Okay. If it's a horizontal line like this, like the horizon, that's 0, meaning 0 fun. If you're on a roller coaster that did that, that's 0 fun. It's called a train, not a roller coaster. And then a vertical line like this actually has an undefined slope. Okay? And that's not fun when you're falling off a cliff like that, so undefined. Okay? Alrighty. Now meet Mr. Slope Dude. You guys might have seen him already in my room, but it's a really nice like picture that helps you remember what line is what with all the different kinds of slopes. So first we're gonna make his eyes. He's got 1 positive, 1 negative. Okay? Then we'll go ahead and put in the eyebrows. He's an angry dude. He doesn't like it. Okay? So the negative eye goes that way, positive eye goes that way. There you go. Next, we're going to do his nose, which is a vertical line, so that means the slope is undefined, U. Now we need the mouth, so a horizontal line. Where's his mouth? There it is. And a horizontal line has a slope of 0. That's Mr. Slope Dude. You guys can decorate him if you want. Okay? Alright, moving on. So, there are 3 ways we're going to be able to find slope. One is from a graph, which we're going to talk about in the next couple of seconds. Next one is from an equation. And the last one is from a, just 2 points. If they just give me 2 points, I can still find the slope from it. Okay? So let's talk about finding slope from a graph. 4 steps, really easy. Step 1, pick 2 points from the line. So you just pick 2 points that are on the line. Okay? Hopefully you're picking 2 points that are actually nice, like points, not decimals or fractions, because that's going to make things very hard. Not that you couldn't do it. In fact, honors are going to have to do it. But just pick 2 points from the line. Then we're going to count the vertical distance between the points. So going up or down, how many spaces are in between it. And then 3, count the horizontal distance between the points. So left or right. And then 4, all we're going to do is put the vertical, which is also known as the rise. We're going to put that over the horizontal, which is also known as the run, and we get the slope. Okay? Things to know really quickly, if you're going up to count from one point to another, that's a positive motion. If you're going down, that's a negative motion. If you're going to the right, that's a positive motion. If you're going to the left, that's a negative motion. Okay? So let's look at an example. So here we have to find a slope from a graph. Alright, so here's our line. Okay? And then we just need to we need to pick 2 points. So where did I put these points? Oh, So I pick the intercepts because usually those are nice, like, points. It doesn't have to be. You could pick other ones. The lines kind of get a little iffy sometimes, but you could pick any of these points in between them. It's up to you. I just like the intercepts because usually those are the ones that are very clearly marked. Okay? So I'm going to count the vertical distance, so the up or down. So I'm going to start at this point. You could start at either point. It wouldn't make a difference, but I'm going to start down here. And I have to go up, so that means I'm moving in a positive way. So I'm going up 1, 2, 3, 4, 5. Oop, I clicked the wrong thing. 5 units. So plus 5 was my rise. Okay? Because I went up. Now I'm going to go to the right. 1, 2, 3, 4, 5 units to get to my next dot. That's my run. It's plus 5. And it's plus because I moved to the right. Okay? If I went from this point to this point, I'd get negative 5. I'd go down, which is a negative movement. So I'd be negative 5 for the rise. And I go to the left, which is negative movement. Again, negative 5 to the left. Either way, I'd give me the same answer because to make my slope, I actually had to put the rise over the run. So here I get 5 over 5, which is equal to 1. If I did it the other way, negative 5 over negative 5 is still equal to 1. It works out. Okay? Alright, so here's yours to try on your own. Sorry, it's a little blurry on my picture, but I think it's clear on your paper. Okay? So, and it's nice because I already picked some points for you, so you can pick any of these 2 points. It could be the top one and the bottom one, which I did badly. It could be some right next to each other. It could be in between. Doesn't matter. It will always give you the correct slope. Okay? So go ahead and pick 2 points, find the slope, pause the video first, pick 2 points, find the slope. When you come back, I'll have the answer. Okay? Good luck. Alright, so hopefully you were able to find your slope. So if you, whatever point you picked would have reduced to 3 over 1, which is equal to 3. That's your slope. So 3 is your slope. And whenever you have fractions for slope, if you did something big, and you got a big fraction, always simplify your fractions, okay? This is one where the fraction is actually better than a decimal because in a fraction, we can clearly see what's the rise, what's the run, okay? And that's going to be very helpful when we actually have to plot a slope on a graph, okay? Moving on. So finding slope from an equation. Now, this is an equation you're going to see a lot. In this equation, y equals mx plus b, this is known as our slope-intercept form, okay? And it's known for that because it has our slope, the m, and the b is actually standing for a y-intercept. So that's going to tell you the y value of when x is 0, okay? So when we're working with an equation to find the slope, we always want to put it in this form because it has our slope right there next to the x. So we're always trying to get y by itself, okay? Literal equations coming back, okay? So let's go ahead and try an example. Here we go. So we have 3x minus y equals 16. We're going to find the slope of the line. So first we have to isolate the y. So to get y by itself, I need to get rid of this 3x. So I'm going to subtract 3x from both sides. If you put the 3x on the other side of the 16, that's fine. It's just I put it on this side of 16 so it can look like the slope-intercept form that we just wrote down. Okay? So the 3x minus 3x cancel each other out, leaving me just a negative y equals 3x plus 16. Now I have to get rid of this negative sign. So I'm going to divide each term by negative 1. Okay? Everything's getting divided by negative 1. And you guys can put these underneath the 16, the negative 3x, and the y. Because I'm working on a computer, I can't really do that as easily, so. Okay? But when I divide everything by negative 1, I get y equals 3x minus 16. That's in slope-intercept form. So now that it's in slope-intercept form, I look, right next to the x, gives you 3, that's your slope. M equals 3. Okay? Go ahead and try this one on your own. Remember, you have to isolate this y first, then just look at the equation and see which one's next to the x, okay? Go ahead and isolate it, figure out your slope. When you come back, I'll have an answer for you. Go! Okay, so you should have isolated the y. When you do that and you see slope-intercept form, you find out your slope is 5 over 2. Okay, meaning the rise is 5 and the run is 2. So you go up 5 and to the right 2. Okay? Alright, next thing, finding slope from 2 points. Well, we picked 2 points. We can find the slope using a certain equation. So when you pick 2 points. You do 2 points. Remember, the x1 and the x2, it just means that they're different x's, but they're both x values. So it's just changing it so you don't get them confused with each other. So you'll have 2 different points. They'll be different values, probably. Okay? And then you're going to plug them into this equation. M equals y2 minus y1 over x2 minus x1. That's going to give you the vertical, or the horizontal, what is this? No, the vertical change over the horizontal change. So you just take it from 0.2 minus 0.1, 0.2 minus 0.1. Okay? So, and again, this formula, you guys will probably have memorized. I want to say it's on your formula sheet, but I cannot guarantee it. So I'll find that out for you by class. So that's the formula we're going to use, so make sure you have it written down somewhere, because you're going to need it for the next 2 problems. Okay? Okay, let's go. See an example. Find the slope of the line given -1, 4, and 6, 3. So you're given 2 points. We have to find the slope. Okay, so here I just laid it out for us. First point was, it doesn't matter which one you label as 0.1 or 0.2. It could be totally different, but it will, like, as long as you keep it straight, that's the only thing. So this part you want to do is label it. So I said my -1 was from my first point, so that's x1. 4 would be y1 then. 6, 3 is my second point, so x2 would be 6, y2 would be 3. So that's what I have. I'm plugging in for this equation, so I just go ahead and plug it in. 3 minus 4 over 6 minus the -1. Notice how I have -1 in parentheses. Okay? 3 minus 4 is -1. 6 minus -1, that's really adding, so that gives me 7. So -1 over 7 is my slope. Okay? So that means I would go to the left 1 space because it's negative, and left movement is negative, and then I'd go up 7 because that's a positive. Okay? Now try on your own. Go ahead and, I will tell you this, I made this one tricky. I did make it tricky, so I want to see if you guys can figure it out. Go ahead and try this one on your own. Okay? When you come back, I'll have an answer. Alright? Good luck. Okay, so you did this. You probably didn't get the correct answer, but you were on the right track because I told you this one was tricky, right? So you do it. What you probably got was 16 over 0, but we can't divide by 0, so that's what an undefined slope means, okay? It means that it doesn't, like, I can't get the run. I can't get a run. The vertical, or the horizontal distance is 0, and I can't divide by 0, so that's why it's undefined, because we can't do that division. We can't, it's not a real number. It doesn't come out right, okay? So that's why a vertical line will always be undefined, and a vertical line is always going to have the same x value, okay? So that's it for slope. Hopefully you didn't have any questions, but if you did, put a little star next to it. I'll be happy to answer it next class. You guys enjoy your weekend, okay? I'll see you later. Bye.